Hi, I'm Scott. Today's electrical day. I've got my Electro Broom t-shirt on. We're going to talk about two of the most common failures that occur to Goldwings. One of them is just kind of an annoyance. The other one will leave you stranded. We're going to talk about how to prevent it, why it happens, and more. Coming up next on GoldwingDocs. Okay, I had to put on a sweater. It's 17 degrees outside today. I can still see my breath in here. I've got the heat on in the garage, but it's not been on that long, so I was freezing. Okay, electrical issues. I mentioned we see two common electrical issues with Goldwings, and we see these reported on the GoldwingDocs forum all the time. I happen to know that these are common, and I know exactly what happens when you get them because I've had both of them happen to me. And yes, I got stranded by one of them. So, let's go over both of those. The first one, the important one, the one we want to hear about, the one that leaves you stranded. This applies to all Goldwings from 1975 onwards up to including today's Goldwings. You're riding along, everything's great, and you come to a stop and your engine quits. And you try to start it and your battery's dead. What's happened? Now, hold on a second. Before we get into this one, I want to make one quick caveat. If you have a 4-cylinder Goldwing and you have not changed your stator plug, then this could be the cause of this issue. The stator plug is a undersized plastic connector that goes from your stator to the regulator. And what happens is you get corrosion on those contacts. The corrosion causes resistance in the contacts. When you put high current through resistance, you get heat. The more heat you get, the more corrosion you get. The more corrosion you get, the more resistance you get. The more resistance you get, the more heat you get. You get the idea. Eventually that connector melts and now your bike is no longer charging the battery. We have lots and lots of people with this issue. I had the issue on my 1100. The solution is to cut that connector out and replace it by just soldering and splicing those wires together. This problem and its solution is covered in depth in the GoldwingDocs forum. I'm going to put a link to that in the description below. So if you have not changed out your stator connector and you have a 4-cylinder Goldwing, you probably need to have a look at that. Okay, on to the one that affects all Goldwings. Every Goldwing has a charging system. The engine turns something, either a generator or an alternator. The 4-cylinder Goldwings have a generator. 1500 and up have alternators. What's the difference? Generator is basically just some wire windings with magnets that spin in the middle. As the magnets spin, it induces electricity in those coils. That goes up through that aforementioned stator connector and then into a regulator. The regulator throws away whatever voltage is generated that it doesn't need. That's called a shunt regulator, and that's why that regulator gets so hot, because it has to sink, basically get rid of all that extra energy. Alternators work differently. Instead of permanent magnets spinning, it has a second set of coils that get energized by a field current. So it basically creates an electromagnet, and it spins that electromagnet inside a set of coils, and that way, by adjusting the amount of power going into the electromagnet, it can adjust how much power is created by the alternator. That's great because you only create as much power as you actually need. You don't have to throw the rest away by heat. And as well, it's a little bit lighter, a little bit easier to maintain. Downside is you have some more moving parts and brushes that are failure points. Okay, so either you have this generator / stator or you have the alternator, and both of those make power. Why does your bike make power? Well, for two reasons. One, you've got to run the engine, all the spark plugs and all the accessories and all the stuff. And the second reason is to charge the battery. Because when you start your bike, it takes a tremendous amount of power out of the battery to start your engine. And that power has to go back into the battery, or else next time you aren't going to be able to start your engine. So the job of your charging system is to create electricity to charge your battery back up so you have power the next time you need to start your bike. Now, what happens if that charging system stops working? Well, you have a backup system, your battery. Your battery will continue to run the bike. Your spark plugs, headlight, everything will run off the battery for a while, depending on how fast you're going, depending on if you have a lot of lights or accessories, heated gear, that sort of thing. You can probably get half hour, 45 minutes, maybe even an hour of ride time just running off the battery. Once the battery dies, or the voltage in the battery gets too low, the bike will no longer create enough spark, and that means the engine will die. So what connects the charging circuit to the battery? Well, big honking piece of wire is what it is, but that's not all, and that's the crux of the problem. As you can see here, I've taken off the side panel of my 1500, exposing the battery. We get a closer look. Now this is going to be looking a little bit different than what you would normally see from a typical 1500 because I have my electrical connections power plate in here. This is an electrical distribution panel for accessories. It takes a high current lead from the battery through this fuse and distributes it to various accessories I have throughout the bike. What we're interested in here is the fusible link located underneath this cover. Now my 1500 is right here, on 1100 it's on the left side. Some bikes it's part of the starter solenoid. On the 4-cylinder bikes, that's where you're going to find it. But let's have it pull this off and get a look. Now this is your master fuse. All the current that comes out of the battery and goes to the rest of the bike, for all the accessories, everything goes through that little tiny piece of metal right there. Everything except for the starter. There's far too much current that goes into a starter to run it through this tiny little strip of metal. Instead, there's a special wire that's thick like this one that goes directly to the starter. The electricity goes both ways through this fuse. If the battery is powering things, if I turn on the key switch right now, power comes out of the battery through this fuse and gets distributed throughout the bike. However, when the bike is running, power is coming from the alternator back up through that fuse and back into the battery. Now here's the problem. If this fuse fails, it takes the battery out of the equation. The alternator is still connected. The alternator is still going to run the bike, not well because it uses the battery as a buffer to make sure the voltage is correct. However, as long as the engine's running, that alternator is going to keep powering the bike. However, it is not charging the battery and it doesn't have the backup of that battery. On the 1500 and the 1800 with the alternator, that's not a huge deal because that alternator is more than capable of running the engine. It will put out more than enough current to run the engine, the lights, and accessories. However, on the 4-cylinder wings with just a stator, when the RPM gets low, the voltage and power that is produced by the stator drops. And it can drop below the level that's sufficient to create spark for the engine. The engine will quit. And then you're stuck. You're stranded because with this fuse broken, you have no power from the battery. That means you can't turn the ignition on, you can't activate the starter. You're stranded. So why does this fail? Well, there's two things that can cause this fuse to fail. The first obvious one is overcurrent. If you have a short circuit and this thing melts, okay, you've got a problem. This thing did its job in sacrificing itself to protect your bike and keep it from catching fire. If that's the case, you need to find and fix that short before you replace this fuse. Don't just replace the fuse and say, oh, well, the fuse blew, I'll just put a new one in. That's not the proper way to do it. If the fuse just fails, it's not actually blown, however, it's no longer working, that's a problem. And that's the common problem that we find with Goldwings. These thin fuses over the years get brittle and hard. A good jolt can cause a crack. And what happens is the ends of the cracks may touch, but once it heats up, they come apart and all of a sudden you have no connection. And the bike cools down and they kind of squeeze back together and now you have a connection. So you might have an intermittent failure. This is exactly the problem I encountered. And when I took this fuse off to inspect it, it actually crumbled into powder in my hand, so I knew that was the problem. There is a simple solution for this, and it's to replace this type of blade fuse with a standard bus fuse. You have to make sure the bus fuse you're installing has sufficient capacity. This is a 30 amp fuse. This would be okay for a 4-cylinder wing. I would not put that on a 1500 or an 1800. We have a look. All it is a standard weatherproof fuse holder. It's got thick wires because it's rated for 30 amps and very stiff because it's cold in here. And you open this up, you insert your bus fuse, plug it in there, you put the wires, connect them, and I recommend you put ring terminals crimped on the end there. In place of this fuse, you would put this in here, and now this is your fuse. More importantly, if this fuse blows or cracks or has a problem where this fuse is no longer functioning in your bike, you're stranded and you are not going to go to the local gas station and find one of these fuses. However, you go to your local gas station, I guarantee they will have a shelf with these bus fuses on there. So if you put one of these in your bike, and I recommend you do it before you actually have this problem, for this reason, because if that fuse blows, you can get a replacement anywhere, and you can easily carry a whole bunch of these in your bike just in case. Now, these bikes did come with a spare set of fuses, and you'll usually find them inside the holder, as you can see right in here. There's my spare fuses. You can't count on that, especially with a used bike, because it may have already been used. You might even have, a lot of the bikes, the covers are actually missing. You might want to check on that, but a better solution is simply install one of these bus fuse holders, and then you have a universal fuse replacement that you can install at any time. So that's the master fuse. That's the one that's going to leave you stranded. Now you know all about it, and you know how to prevent it. Before we go on with the next common Goldwing failure, have you subscribed to this channel yet? If not, go ahead, click that subscribe button down below, and then click the bell right next to it so you get notified whenever we post a new video. It really helps us out when you do. And if you like what you're seeing here, click that like button too. Leave us a comment, let us know what you think. Let us know if there's any other videos you'd like to see. All right. If you have a GL1000, a GL1100, a GL1200, 4-cylinder wings, this applies to you. If you do not, if you have a 1500 or 1800, this does not apply to you. So you can either click away now, or if you're interested and you want to find out, keep on watching. So there is one exception. If you have an 1100 or a 1200 with a digital dash, this also does not apply to you. This is only for the 4-cylinder wings with analog gauges. That means you have a tachometer, round tachometer, and a round speedometer. If you have that, this is for you. So it's a nice spring day. I'm out riding on my 1100. I look down at my gauges and I have a heart attack. My heat gauge was pegged all the way to the top, past the red. I'm thinking, oh my God, I've blown a gasket. Something's seriously wrong. And then I noticed the fuel gauge was also pegged all to the right, which is odd because I knew I had only about a quarter tank remaining. I thought, something's not adding up here. There's no steam coming out of the engine. I don't notice any excess heat. Why am I suddenly overheating and my fuel gauge is also showing maximum fuel? I thought something's not quite right there, but I'll keep an eye on it and I'll head for home now. A few minutes later, I look down and my temperature gauge is now showing all the way cold and my fuel gauge is empty. I thought, okay, definitely got a gauge problem here. This is one of the most common electrical failures on the 4-cylinder wings. As I mentioned before, you have a stator that varies with the speed of the engine, and as that engine speed changes, it puts out a different amount of voltage. So at idle, you might be only putting out maybe 9 or 10 volts from the stator, whereas at full throttle, it can put out 18 volts. Now, a lot of that is absorbed by the battery, but the voltage does fluctuate quite a bit. Now, that's regulated, of course, so you get between 9 and maybe 14 volts, 13.8, 14 volts, if everything's working properly. The battery will absorb a lot of that, but still, that's quite a variation in between 9 and 14 volts. So if you have a voltmeter on your 4-cylinder Goldwing, and you come to a stop at a stoplight, you're gonna notice the voltage sags way down. You may even notice that your headlight gets a little bit dimmer. If you rev the engine up, it all comes back up again. The voltage on the 4-cylinder Goldwings does vary quite a bit. So now we have meters that work electrically, and they depend on a specific voltage to show a specific indication. How it works is power comes from the bike, goes through the meter in the dash, and then through a single wire down to the sensor. Now there's two sensors, one inside the fuel tank, one that's a temperature sensor that's embedded into the cooling system so it measures the coolant temperature. Both of these are just variable resistors. As the fuel level changes, as the temperature level changes, the resistance changes and allows a little more or less current to go through. So when your fuel tank is full, the resistance is the lowest. So the most current goes through, the meter goes all the way up to the top. When your bike is the hottest, the resistance drops down to the lowest, and again, the temperature meter goes all the way to the top. But if those meters are measuring a specific amount of voltage, and that voltage is fluctuating depending on the speed of the engine, how are the meters ever accurate? Well, the answer is there's a second regulator. There's a 7-volt regulator that watches the system voltage, and the only thing that 7-volt regulator does is clamp that voltage at 7 volts so that the meters, the temperature and voltmeter, are accurate. So it feeds a steady known 7 volts, and the meters are then calibrated for 7 volts. So When it sees a full 7 volts, the meter is full scale. It's a fantastic system. It works very well until it doesn't. The 7-volt regulators are famous for failure. They aren't made anymore. They haven't been made in a very long time. And that's exactly what happened on my 1100. The 7-volt regulator failed shorted, so instead of a 7 volts, it was feeding the full 14 volts into my meters, which is why they pegged themselves regardless of the resistance of the sensors. Or they fail completely and no voltage gets through and the meters go to 0. And a lot of the time, when the 7-volt regulators are failing, they start failing intermittently. So you'll see full scale, sometimes they'll work and then they won't work, and then sometimes they'll be full scale and then they'll be working properly. And you'll typically see that for a few weeks before it completely fails. Now it's definitely something you want to get fixed, because if you have a 7-volt regulator that fails shorted and it's feeding that full 14 volts into the meters, you can damage the meters. The meters are only meant to measure 7 volts. So if you're feeding 14 volts into those tiny, tiny little coils inside of the meters, you can actually burn out those meters. So it's definitely not something you want to ignore. So we just have to replace the 7-volt regulator, right? Well, yes and no. My 1100, I thought, well, I'll just figure it out. I look at the circuit, oh, 7-volt regulator, okay, I'll go find one of those. Well, they don't make those anymore. You can't get them. Well, I can find a used one on eBay and it's $40, and who knows how long that one's gonna last before it dies, or maybe it's already dead, who knows? I thought, I know electronics, I've got an Electro Boom shirt, I'll make my own 7-volt regulator. So that's what I did. I made a replacement regulator, put it in, fixed, good as new. I made the mistake of mentioning that on the GoldwingDocs forum. Somebody said, hey, could you make me one? Mine's failed too. I thought, sure, I'll make another one. So I made one for him, sent it off. He mentioned it to somebody else on another web forum. All of a sudden, I have 10 people asking me, hey, can you make one for me too? I thought, I think there might be a business here. So I started making 7-volt regulators. Here's one of them right here. That was just over 10 years ago. And in that 10 years, I have sold thousands of these. Literally thousands of them. And I make all of them by hand. So yes, I've spent a lot of time and effort making these, and my legacy is that there are thousands of Goldwings all over the world who have meters in them working because my 7-volt regulator is in there powering them. It's solid state, it's potted, it's reliable. I have never had anyone report to me that one of these has failed. Not once, actually once. I had one guy who looked at the color of the wires and said, wait a second, these connectors are on wrong because black is ground. So he cut the connectors off and swapped them, not knowing that in the world of Honda, green is actually ground. So what he ended up doing in essentially was shorting out the regulator completely, and he smoked it. Smoke literally came out of it, so don't do that. But other than that one, I've never had one come back failed. So if you have a 4-cylinder Goldwing, a GL 1000, 1100, 1200 with the round analog gauges and the analog temperature and fuel gauges, and they're starting to act up, go to the GoldwingDocs website, order one of the 7-volt regulators. It comes with a full set of installation instructions. It's not tough to do. Like I said, thousands all over the world, people install it themselves. Actually, a lot of motorcycle shops around the world also order these and keep them in stock to put in when their customers come in with failed 7-volt regulators. So I suppose that means my 7-volt regulator has actually become the de facto aftermarket replacement for the Honda Goldwing regulators. And actually, it's not just Goldwings that Honda use these on. I know there are CXs, there's a number of different motorcycles from that era, all of which use these 7-volt regulators, and people have figured that out. So I have people buying these that aren't putting them in Goldwings at all, they're putting them in other Honda motorcycles. So if you're having a problem with your fuel and temperature gauges on your 4-cylinder wing, have a look at our 7-volt regulator. Now, don't buy this regulator if your temperature gauge is working fine and your fuel gauge is not, or if your fuel gauge is working fine but your temperature gauge is not. It's not your regulator. Only if both gauges are malfunctioning the same way, if they're both pegged or they're both at 0, then it's your 7-volt regulator. If one's working and one's not, the problem is more than likely a wire between the meter and the sensor or the sensor itself. One of the most common problems is people will take their bike apart and they'll put it back together and pinch one of those wires and short it out against the frame into ground. So basically, instead of the voltage going through the sensor, it's going directly to ground. And if that happens, the shorted wire will cause the associated gauge to read full scale. So if I'm working on my bike down underneath a seat and there's a fuel sender on there, and I put it back together and I crush that wire against something and short it out, my fuel gauge is going to go full and my temperature gauge is going to work normally. If that's the case, it's not a regulator. It's exactly what I just said, the wire. Now, same thing goes if the meter is down to 0. There could be a number of things. Most commonly, the wire has been cut or the meter itself has failed. Well, I hope this video has been of some help to you. Once again, if you like what you see and you find any of this useful, please go ahead and click like, subscribe, click that little bell, and again, I love your comments. Anything you have to say, any suggestions for future videos, please go ahead and leave them down below. Thanks again for watching.